Well, good morning, good afternoon, or good evening, depending upon where you are in this world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap today, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand. We'll be sending out an email post-event with a link that you can access the webinar. And we are taking questions from the audience. So if you have a question at any time during the webinar, please don't hesitate or wait. You could use your GoToWebinar control panel and submit your questions. And we will take about 10 or 15 minutes near the end of the presentation and go over the audience questions. And finally, we do have 2 polling questions during today's webinar, so we hope that you will participate and submit your answers, and hopefully we'll all have a good time doing it. So let's go ahead and kick off today's webinar, which is Modernizing Testing as Apps Re-Architect. Our speakers today are Al Wagner, who is Technical Evangelist at IBM Cloud DevOps, and Chris Hagen, who is the Product Manager at HCL Technologies. Welcome, gentlemen. Thanks for joining me today.
Good morning, Charlene. Thanks very much, and thanks for everybody who's in the audience.
Excellent. Thanks for having us. I'll go ahead. Yeah. Alan, I know you are starting off, so I'll go ahead and just turn it over to you, let you do your thing.
Okay, well, a little bit about myself before we get into this. My name is Al Wagner, as Charlene pointed out. I've been with IBM for 17 years now, but I've been in IT for about 22 years, starting off as COBOL PL1 mainframe programmer, advancing through Visual Basic Power Builder on route to Java. I've been a tester, both performance and functional tester. I've helped the operations people solve challenges in production, worked with the release team, and more recently, I'm traveling around the world talking to customers about DevOps adoption and working through some of the challenges that they're facing, and looking at it from a process optimization point of view, as well as a tooling to help with the automation piece of it. Let me get Chris a chance to introduce himself, and then we'll get going.
Thanks, Al. My name is Chris Hagen, and similar to Al, spent a long time in this industry, over 16 years or so. Formerly doing a lot of work around the API testing, service virtualization space, talking to a lot of organizations about how they can get in and start testing. Originally, back on in the days of EAI-based integrations, and then SOA-based, and now we're into the world of microservices and REST and that sort of thing. So a lot of time spent in the API service virtualization space. Today, I find myself as product manager of the functional and performance testing parts of the portfolio, which really gives me an opportunity to start to connect some of the the different testing realms together and start to say, well, how do we get value at all of these different layers? And we'll talk about some of that as we go through today. Over to you, Al.
Okay, thanks, Chris. So, really, what are we talking about today, folks? As I am traveling the world, as I mentioned, I'm talking about this digital transformation momentum. And moving to cloud, really embracing cloud technologies because they give us flexibility in where we can deploy our workloads. They give us agility in, being able to scale new environments very, very quickly, or solve challenges in production very, very quickly. And there's a lot of new technologies that are available to help us with this move to cloud. And, digital transformation, it's about really changing how we interact with our customers, getting new interfaces, new points of engagement to them as quickly as possible, so that we can disrupt the market, either beat the competition, increase revenue, or build a new market share. And as we're moving to the cloud, we're really looking at how do we take our monolithic applications that are sitting on physical infrastructure, perhaps on-prem or data center, and start to re-architect them in a manner that will allow us to take advantage of cloud technologies. And the 3 ways we typically talk about it is a lift and shift, a refactor, or a rebuild. Now, these are not exclusive as to I can only do one of these at any one time. We may have multiple teams approaching this transformation through any one of these three ways. And if we look at these, if we look at the monolithic implementation on a physical server, chances are it probably has a dependency on another system. Now, some organizations are taking these monolithic applications and they're picking them up and they're either deploying them as images inside of a cloud environment or they're containerizing them. But it's still a monolithic application. There's still some complexities around deploying new capabilities within that. There's still some latency in how quickly we can test those monolithic applications because of all the change that's happening. There's challenges around how quickly we can deploy. So, that lift and shift approach is our fastest way to get to a cloud platform, but it may not offer us the most amount of flexibility. The second way is refactoring, where we start to look at our application and decouple pieces of functionality into encapsulated containers. So maybe we peel off the user interface layer and we create that as a container, and we have maybe a business function that's stateless and decoupled from the rest of the application, and we have that in a container. But maybe we've got a couple of pieces on this journey that are still going to be linked together inside of a container or sitting in a VMware image or on physical infrastructure, and we may still have dependencies to other systems. What comes to mind is maybe I have to reach back to a ZOS environment, or I have to reach back to an SAP system. Both of those systems are very, very complex in provisioning, or can be complex in provisioning. Takes a lot of manpower, and there's sometimes scheduling constraints when I'm looking at testing those integrations between these back-end systems. The third is the rebuild, where we start to decouple and decompose that monolithic application into these smaller bits. And by that, it helps us with speed in deploying, because as we make a change in one, we may not have to modify the others. And this allows us to quickly deliver that new capability. But again, we could still have dependencies on these back-end systems, which can be a lag as far as being able to test them. So I like to put this slide up to kind of get a sense of where we are, because a lot of the customers that I've chatted with are still in this kind of a model. They have some stuff on a monolithic application, or they have stuff sitting on a mainframe, or they have an SAP or an Oracle implementation on a physical server inside their data center, or they have constraints around compliance where their data must reside on-prem inside a data center for protecting personal information. Some companies have LPAR'd off big servers and created multiple VMware images, or areas where they can deploy these VMware images, identifying how much compute power would be assigned to each one of these partitions. Some companies have taken those images off of an on-prem site and put it into a cloud. And we hear things like, it's not just one cloud provider, it's many cloud providers. Where is it most cost effective to run that particular workload? And then we've got these containerized applications that could be sitting in Docker. So this is the place that I see many of the customers today en route to this digital transformation and embracing cloud technologies. But as we move into decomposing these applications, we start to decouple our monoliths and start to create microservices that are running inside of containers. They have to be assembled. So now we've got dependencies across these individual microservices containers that need to talk to one another, because are we truly getting to a 12-factor application where they are fully decoupled? Perhaps not. Some of these complex systems, it's very difficult to get that level of decoupling. And we still could have these microservices calling back to these mainframe environments or to these legacy ERP systems or our legacy Java applications. It's really a situation where, as I'm talking to customers and I put this slide up, where are we on this journey? And I called out, they're typically into getting to the cloud level or monolithic applications deployed as containers, but some are moving into these microservices worlds and, leveraging technologies like Docker and Kubernetes. But, they're deploying applications across an environment that looks like this. And this really adds to the complexities with respect to testing, as I've got dependencies. How do I provision these environments so that I can test my application? do the development teams and the test teams, while they're subject matter experts with respect to their application, do they really know what the environment needs to look like? Have they got the security policies in place? Have they got the monitoring in place? Have they got all the things that helps build trust between dev tests and the operations and the security and the infrastructure architects? So now we're getting into, I'd like to get a sense of where we are on this journey for those that are in attendance. So Charlene, can we put the first poll question up, please?
Absolutely. I'm launching it right now. It should be on your screen. The question is, where are you on the transformation journey? You can select one of the following. Adopting cloud is not on immediate plan. Currently deploying applications as VMware images on cloud. Currently deploying monolithic applications as containers. All in on microservices, containers, and Kubernetes, or a mix of physical installations, VMware images, containers only. So give you guys a few seconds to submit your answers, and then we'll take a look at the poll results. All right, great. Also want to remind, I'm sorry, go ahead.
Sorry, I was just going to say, whilst people are filling in that poll, I think I'd just like to add a little bit of color to one of the things that that Al mentioned earlier on about the different ways that people go through the different transitions. We talked about lift and shift and rebuild and that sort of thing. One of the things I've noticed talking to a lot of organizations is that what can start out as, and quote unquote, simple lift and shift, it very quickly becomes a case of, kind of like, whilst you've got the hood up on this application, let's make a little, this has always bugged us. Can we make this change? Can we do this thing? It's very interesting to see, people's progression as to how a lift and shift and that sort of thing can start to become a case of, oh, well, now I've got, some focus on this application, and then it's like, oh, well, whilst we've got the focus on the application, now we can start to make a choice about decomposing it into things like microservices and that sort of thing, because we're already going through that sort of investment cycle. So just a little bit of a additional color to some of the things Al was talking about before.
Okay, yeah, all right. Well, let's go ahead and close out the poll now and take a look at the results. Looks like the majority of people do have a mix of physical installations, VMware images, containers, and so forth, which frankly doesn't really surprise me. Gentlemen, what do you guys think of these? Yeah.
That's what I hear. It's truly a journey, and that's what I try to echo at the various events when I'm talking to the clients, that I'm not surprised by this. There's some challenges that we're going to talk about as we go further into this presentation on how to solve testing these types of deployments. So no surprise here.
Okay, great. I'm going to go ahead and hide these results and let you get back to your presentation.
All right. All right, so really what this is getting us into is what the analysts are calling multi-speed IT or dual-speed IT. I like to think of it as a multi-speed world. We've got, these teams that are building these new interfaces, these microservices. They're able to move very quickly. They're born on the cloud. These teams are structured in a way that are highly agile. They're using technologies in the delivery pipeline to facilitate a release cycle that could be immediate. It could be hourly, daily, weekly. But the thing is, like I mentioned earlier, they have to call back often to these industrialized core, these systems of record, the infrastructure that the business depends on, where we get to an impedance mismatch between the teams that are working in the innovation edge and the teams that are working on the industrialized core. If we're dealing with Z systems or power systems or Java-based systems, there's maybe they're waterfall or what I call Wagile or Scrum fall. They're focused on predictability. They're the core legacy systems. And if we have to have a coordinated change between, this new microservice that the innovation edge team is building and then it's going to make a call back to a legacy system that's being updated. It's very easy for the innovation edge team and the systems of engagement team to wrap new functionality in feature flags to hide it and deploy to production regularly. But when we're talking about these dependencies on back-end systems, we want to make sure that that feature that's wrapped in that feature flag actually is working properly before we promote to production. So how do we work in this world where we've got teams running at different release cadences on a journey to deliver new capabilities into the production world to support the business? One of the biggest bottlenecks is, how do I stand up an end-to-end test environment that spans all the technologies that I need, gives me availability of applications from other teams, resolves issues around dependencies? I've only talked to one customer out of the thousands that I've chatted with where they have multiple mainframe environments. That's typically not what I hear from many others. So we could run into scheduling dependencies or conflicts. Do I have a device cloud that's going to give me the various physical mobile devices that I need to test again? Do I have realistic production systems? Do I have access to third-party APIs? In this case, a lot of times in this API economy, we are dependent on services or capabilities from other organizations. Maybe their development teams are not working at the same rate, so we've got a mismatch here. Or maybe there's a cost associated to each time we touch that third-party API. All of these things, are driving up the costs of IT, which is something we're trying to lower in this DevOps movement. And then in predictable functionality, we need test data that is realistic and complete, whether it be abstracted from a production environment or fabricated through synthetic test data creation capabilities. But we need to have test data so that we can validate the message being sent or the action that we're performing is we have a predictable outcome. And then we can rate that predictable outcome about what really happened so we can define whether it was a defect or not. So waiting for these environments is really a time sink. If we look at Agile, the developer teams are moving very, very quickly. Hopefully the test teams are getting to done, working within that sprint. But often that test environment may just not be there yet. And as we wait, we start to get a disconnect between what the developers are doing and what the testers are doing. And as if we allow our dev teams and our test teams to provision their own test environments or define what their test environments look like, maybe some pieces are missed. Maybe there's a trust deficiency between the development team and the test team and the operations team, the people that need to make sure that the environments are set up properly. All of this time sinks. So, and then in DevOps, one of the things is to accelerate closing of that feedback loop. So as we get new products into the hands of the consumer or the end user, what is the feedback on the quality, on the functionality that's been delivered? Does it meet their needs? But inside that delivery pipeline, there is feedback loops along that entire step. And the faster that the testers can provide feedback to the programmers on the quality of the applications as it's moving through that delivery pipeline, the better off we're going to be. So if we look at this test infrastructure on demand, and in the DevOps world, we could have multiple product teams. We've got our developers, we've got our testers, and typically we talk about these product teams being a representation of all of the different groups that make up that delivery pipeline. The reality is that I'm hearing from people as I'm out in these events is that there's just not an operations person or a DBA or an infrastructure architect or a network architect or a securities compliant person or, available on each one of these product teams. We're talking about a pool of shared resources. And, I'm calling them, for the purpose of this webcast, the infrastructure product team. They are the ones that are responsible for instantiating and looking after production environments, making sure that they are protecting the business, making sure those environments will scale, making sure that the databases are up to date, making sure that monitoring is in place, making sure that the security policies are in place, intrusion protection or enterprise scanning level types of checks on on the vulnerabilities of the application, or hopefully lack of vulnerabilities. They are managing the connections between these various systems through API gateways. So what if we were to equip them with virtual services and test data that they could help or provide the assets to build those test environments on demand? If we look at that scale from test to stage, early on in testing, perhaps product team A, who's working on that innovative edge piece, they need to access a mainframe environment. But do they need the physical mainframe environment, or can they use a virtual service to intercept that call to the system and respond with a realistic response, or behave in a similar way to the mainframe application, so that we can at least get feedback on the quality of that call without having to actually stand up that environment, that mainframe environment. And as we get closer to stage, our dependency on these virtual services starts to decrease or become eliminated, where at the stage level, we're actually testing against real systems pre-production so that we can move into production with confidence. But if we let the infrastructure product team define what that environment looks like, then we move towards the trust piece between the dev and the ops. And you'll hear a lot about DevOps engineers or site reliable engineers. This is a role that's coming into, well, it's been there for a while for some in organizations that are relatively new to this. It's really this team that is focused on making sure that we have environments that align to corporate standards and policies. And we can model test environments based on our production implementations and use things like virtual service to simulate some of the dependencies in early test stages, again, without having to actual provision the physical environments. So that's a way that we can deal with the test environment. And there is technologies in place that can help with that. But the other challenge that I still hear at these events is when I start polling the audience around levels of unit testing or maturity around test automation, I still hear that we're doing a lot of manual testing. And in a previous role about 4 years ago, I polled the testing industry from about 600 different respondents with multiple years of experience, and we still had a very low level of unit testing into our continuous integration process. Limited security testing around scanning our source code to make sure that it is compliant with our coding practices. And if I look at this, if we're doing it all manual and we're accessing our applications through a user interface, a lot of the complexity of that application is really below the surface. So when I'm talking about delivering feedback to my core group, my development team, if I test through the UI and I get an error condition, I'm going to send a defect back to the developer saying, I tried this, I got this defect, or I got this incorrect response, then to create this defect. What actually happens is the developers are going to have to then look at, server logs and drill in and turn on debug capabilities so that they can diagnose and triage that issue. What if we pushed our testing down? What if we drove testing, did more unit testing, did more API integration level testing? Now, in each test stage, I'm not saying that we only do unit testing and then in the next stage we only do integration testing. What I'm trying to present here is we do in each stage a level of unit testing, a level of API testing, a level of UI testing, as well as performance testing along with security scanning. And if we can automate that and leverage service virtualization, we can isolate these defects. We can give a defect back to the programming team that says component A was talking to component B, that message is not working properly. We've isolated it, and it gives them an opportunity to remediate that problem faster. So with that, Charlene, I'd like to put up a second poll question asking the audience around, where are we on our test automation maturity journey?
Okay, launching the poll right now, should be on your screen. What percentage of your tests have been automated? You can select one of the following. All testing is done manually. Less than 25% of tests are automated. 26 to 50% of tests are automated. 51 to 75% of tests are automated or more than 75% of tests are automated. Go ahead and make your selection. And while we are waiting for everybody to do that, just want to remind the audience that if you have a question for Al or for Chris when he does his part of the presentation, feel free at any time to submit your question using the GoToWebinar control panel. And then, as I said earlier, we'll take about 10 or 15 minutes near the end of the presentation and go through those audience questions. Okay, Chris, while we're waiting, you have any comments regarding what Al's been talking about so far?
I'm always happy to add a bit of color. So yeah, so I think it's interesting. There's some good stuff that Alan's been talking about in the last few slides, and one of the slides that he had earlier on, where he was talking about multi-speed IT and that sort of thing. I think one of the things it's very easy to sort of lose sight of is exactly how that impacts the end user. Okay, what is the user experience that is that is driven by things like multi-speed IT? So to give an example, my bank has a mobile phone banking app. I'm sure most banks do these days, and it's regularly updated. Right, there's new features, new functionality available on my mobile banking application every few weeks. Okay, but I'm pretty certain, and in fact I know because they're one of our customers, they don't update the mainframe every couple of weeks. That's not how this is working, right? So they've got infrastructure and processes in place that allows them to build out these, this innovative edge technology, whilst also having, the systems of record and, what Al was terming the industrialized core, exposing that in a way that is flexible for, for their application teams to actually deliver more value to customers.
Interesting. Okay, let's see. It looks like everybody has submitted their answer who's going to. So I'm going to go ahead and close out the poll now and share the results. All right, looks like the majority have a quarter to half of their tests automated. Alan, again, does that jive with what you're hearing out there?
Yeah, that maps pretty close. I'm glad to see that, over the last couple of years, there's been an increase in automated tests, and a decrease in the amount of testing that's done manually. Because really, in the name of the game in DevOps is lean, agile, being able to deliver with speed and deliver high quality software with speed. And that's key, right? Anybody can quickly deploy bad software into production, but do we have the right quality gates in place to make sure that we are satisfying the needs of our customers and delivering applications that function as expected or as desired? So I've seen some improvements. This is a positive step.
Yeah. It's interesting. I mean, for these poll questions, we've gone for very quantitative style questions. I do wonder, actually, if we were to ask a more qualitative question and say, what do you feel about the quality of your test automation programs? I wonder what the answer would be. But that's a different poll for a different day.
There you go. Keep that in your back pocket for the next time.
Yep.
Okay, I'm going to go ahead and hide the results and let you get back to your presentation.
Okay. So, one of the things that I've also discovered in chatting with the client at the events is how do we deal with, simulating these dependent systems? And, a lot of them will come back is, well, we write a mock, or we write a fake, or we write a stub, similar word for the same outcome. And, is that really productive use of my programmer's time? They're typically going to write a stub or a fake that meets their needs. But then along comes their friend and says, hey, that's really cool. I could use that. Could you add this other condition to that? And so on and so forth, where that programmer who initially created that mock or that stub is, spending an awful lot of time maintaining it, updating it, coding it, you got to test it. It is code, so we're debugging, and this starts to take away time from what their core mission is. In the DevOps world, our focus is to deliver business results. And business results come in the form of disrupting the competition and getting new software innovation into the hands of the end user extremely quickly. So time spent writing this mock, and I've polled people at these events asking them, how much time do you actually spend in creating that mock? And I'll hear words or time frames that are, well, it could take us a day if it's a really simple one. It could take us a week. Well, in most cases, sprints are 3 weeks long, and if I'm spending a week of it writing a mock or maintaining a mock, it's kind of a time sink that I could eliminate in my quest to become more agile and lean and leverage perhaps a commercial software solution that could help solve this challenge. There's a number of them out there. We have one, but this could be a good question too, Chris, about who is writing their own mocks, because I think teams really need to look at this. Yes, they have value, but do they scale? Are they easy maintainable? Can they be deployed to the enterprise that allows the team to use them? That's the kind of capabilities that the commercial software offers with respect to service virtualization. Any color there, Chris?
Careful, Al, you're treading on my next slide.
Let's go there. Let's hand it off to you, and you start telling them about some of the solutions to solve these challenges.
Yeah, and I think you made some really great points. When we talk about in the last slide we talk about maintenance, and maintenance is certainly a big problem, particularly in the world of mocks. I would also, and you just touched on it just at the end there, about a lot of organizations, again, teams that I talk to, they're very insular. Okay, this idea of sharing things with the rest of the organization is sort of like, well, why would I want to do that? What value does that add? But things like virtual services are actually a really good way of sharing value around your organization. So if I've built a virtual service for a particular component to solve a business problem that I have, well, there's a reasonable chance that we've got other projects and programs of work that are going on that are also going to struggle with that same component, that need that same sort of virtual service. Having a way to share that is really, really useful, really important, especially in these larger organizations where discoverability, particularly of reusable assets, is, I think, crucial. So that kind of leads us nicely into this idea of, what are the things that you need in a virtualization solution? And we've got some great examples up on the slide here about, virtualizing dependencies to accelerate development and testing, helping with complex situations and that sort of thing, reuse of APM data to provide realistic response times. There's all sorts of capabilities that you can bring to bear to create virtual services that accurately and easily represent real-world systems that you need to work with. But the value that they're bringing is that decoupling from these dependencies, from components that may not be available. Maybe they're owned in your organization. They're things in your organization that a different team is building, and they do a deployment every Thursday, right? Every Thursday, 4 o'clock, they do a deployment. And that means Thursday from 4 o'clock onwards, your test team are just sat there twiddling their thumbs because the dependent component that you're working with is unavailable. I've actually worked in an organization like that. The test team loved it. 4 o'clock on Thursday, that was when they knocked off and they went to the pub. Okay, great. Muggins here comes in, brings in a virtual service and says, you know what, you can use that time. You can still be testing. I made a lot of enemies that day, but the project managers, that was really good for them because suddenly they're not losing time every week to deployments that they have no control over, right? Now they've got control over the virtual services. They've got control over what's in that environment. They can modify that virtual service. So now they've actually got better capability than they had with the real service. They need to be able to say, I want to generate an exception scenario. Well, they can do that with their virtual service because they've got control over how it responds to particular requests. So it's really a very powerful, powerful capability. Now, as we look at moving on to things like integration testing and how do these things work in larger organizations, what you tend to find is this concept we call incremental integration testing, whereby you're working on a particular piece of code. And you can see this on the left-hand side here in the middle of, we've got this little blue dot. This is the bit of code that I'm working on that I have complete control over. But in order to test that, in order to work with it, I've got some dependencies. I've got areas where I need to exchange data. And on day one, there's quite a lot of that, quite a lot of things that don't exist yet because I'm still writing them. And so I build virtual services so that I can test the core of my application. As I go through that application lifecycle, more and more of those dependencies become concrete. I've actually created that code. It's available to me and I can have it in my environment. And so we see over the period of a project delivery, you're going to become more and more, going to have more and more availability of these actual services, and your virtual services start to fall away as you move towards production. But that doesn't mean that they lose value, right? Those same virtual services that I built to support my application, well, they still have value in my earlier stage environments. I've just delivered version 1. If I look at this and I follow these circles, let's say this is version 1 of my application. Well, coming hot on the heels of version 1 is version 2. And you know what's coming behind that? Version 3 and version 4 and so on and so on and so forth, okay? And all of those environments are going to have dependency restrictions around them. And so we can keep using those virtual services throughout those life cycles. And when I'm done with this project, those same virtual services may be useful to other parts of the business. Now, there are a number of ways that we go about virtual service creation. We've broken it down here into these 4 pillars, and you'll see this model as we talk about some of the other capabilities in just a moment. But we say, well, okay, what is it that we need to do in order to build an effective virtual service? First of all, we need to understand what are the endpoints, what are the things that we're trying to virtualize, what is my dependency? Once I understand that, I can build the model. I can say, okay, well, this is the way that the system interacts. These are the data formats that we're using. This is the connection properties. It's got this security applied to it, etc., etc. Once we've built out that model, we can then build the virtual service from the model, and we can say, okay, well, now I've got this codeless representation of my dependency. I'm going to attach some data to that because it's all well and good understanding the way that your virtual service should respond, but it needs appropriate data to be able to respond with. And once I'm comfortable with that, I then want to think about sharing it, okay? Real value from virtual services comes from when they are shared amongst the whole team, and that's where I publish that out to the rest of the organization for reuse. And so that then brings us on to, well, how can we actually start to take this type of approach, this type of application modernization story? It's great that we've got API testing, we've got service virtualization. How do things like functional testing apply in this world, where I'm still, as Alan was talking about earlier, we still have these systems of engagement. We've still got this mobile device with this application on it that's moving at a rapid pace. And so what we want to be able to do is scale out our testing in such a way that we can take advantage of new technologies and new capabilities. And so one of the ways that we do that is by saying, okay, well, I can take my application, my functional test, and I can scale that horizontally. Right? I can scale it out in containers. I can put that on tools like IBM Cloud Private and gain a ton of advantages in terms of scalability and speed of execution. Okay, but suddenly I'm running 20 test cases at the same time rather than running in serial and that sort of thing. Parallelism is a great advantage here, and IBM Cloud Private gives us some great scalability capability there. Now, of course, because these are Docker containers, you can run these in your cloud vendor of choice, but you get this great benefit. Now, adoption for this sort of capability follows the same basic principles as we have for virtualization and API tests and those sorts of things. We want to understand what the process looks like. So we go through a define stage where we say, well, what is it that we need to test and how does that work? We're going to elaborate on that. Again, we're going to start to understand, well, what are the validations we need to apply? How does the page represent itself when we're actually running against it? At runtime, we're going to do the same sort of things that we did in the virtualization scenario. We're going to apply data. I want to test this through a number of different scenarios. And the reality is that the business process flow is probably the same. It's the data that's going to change. And so how can I attach data to that and make sure that that works? And then finally, I want to be able to scale that. I want to be able to run it either in containers or virtual machines, whatever it is that you're comfortable deploying, but I want to get that scalability. And so we can put that into elastic capacity tools like IBM Cloud Private and that sort of thing in order to get those results and reports much more speedily. Okay, so that's functional testing. So that's understanding, how does the application behave for a single user? And then the question becomes, okay, well, what happens when we're applying load across across this application? How can I do that? And so we come to this point of saying, well, I can take that same functional test case, we call it the gold master, and I can turn that into a performance test. And that performance test can then be run and scaled on a number of different tools and technologies. That could be bare metal servers. We could be using pure Docker. We could be using some sort of cloud provider like IBM Cloud Private to scale our load generators, all of which are attacking your system under test and generating the load. And at the same time as we're generating that load, we're also doing a number of verification processes in order to capture things like the resources in use and that sort of thing. So we've gone from this idea of having a single user process flow to saying, okay, well, now that I've scaled this out, I need to be able to capture a bunch of metrics. And I want to understand two things. First of all, I want to understand the impact at a low level, at a low scale. So that single user test still has value to me, right? Anybody who's been on a diet may have heard the phrase, a moment on the lips, a lifetime on the hips, right? I'm not saying I need to go on a diet, but I've heard the phrase. When you're doing a single user performance test, any anomaly that you see there, well, that's going to be magnified when you start to apply real load, okay? And so we start to say, okay, well, let's take that low impact information and start to highlight to our users, this is an area where we need to focus in on. We need to understand what's the problem, what's the problem going to be like at scale? And so resource monitoring and performance enablers like that are a real benefit. The Gold Master technology that allows you to take a functional UI test, turn that into a performance test with just a couple of clicks is a real time saver, and the maintenance problem just goes away. It's a great capability. Now, again, what's the process for adoption? Well, would you believe it falls into these same four pillars. We want to define what it is that we're trying to test. And again, we can take that same single user scenario and scale that. So actually, we can take some of that same information that we got from the functional test and reuse that. So that's great. We've got a leg up there. We're going to elaborate on that in exactly the same way. We're going to apply our rules. We're going to apply correlation information. We're going to make sure that my performance test is going to adapt to things like different cookies and all of that sort of stuff that might be happening. We're going to apply some monitoring to this. We're going to say, okay, what are my SLAs and what criteria do I need to use to verify whether or not this performance test run meets my acceptance criteria or not? Okay, so it's not just about can I get from point A to point B in the application, but when I go from point A to point B, is it in the bounds that I've set within my goals? And then the way that once we've defined those SLAs, we've set up that monitoring, then we go to scale, and then we take advantage of, as we said before, bare metal, VMs, containers, whatever it might be. And how do we get to scale? We've got, again, elastic capacity and ICP, et cetera, et cetera. So that takes us, I guess, into, what is the solution here? We have a number of tools and capabilities that come together to provide this capability, and they are all more and more tightly integrated. So, if you've got an API test where you're invoking against, let's say you're working against I don't know, pick something like TIBCO, for example. You're working against a TIBCO environment. You can take that same test case, you can put that into your performance test capability and just scale it. Okay. So what was originally a functional test for a particular API scenario, you just a couple of clicks, import it, define the load criteria, and you're off to the races. So this integrated workbench allows you to have that overall overarching control process. And of course, at all these points, you could be using your virtual services. We've got a number of customers who use virtual services to support performance test environments. I got an email the other day, and it was, somebody saying, we've done some analysis, and in our performance test environments, we reckon we've done, and I forget exactly what the figure was, but it was in the hundreds of millions of transactions against our virtual services because we're using them regularly to support our performance test environments. And I think that speaks volumes to the ways that these things can be brought together and used as a complete solution.
Chris, I've heard of a couple of users of this technology that are able to provision their entire test environments using just virtual services and inserting the new functionality that they want to test again, which is a tremendous way to make a test environment available and speed that feedback loop.
Exactly.
And they're using it for both functional API and performance.
Yeah, and the thing is, we're talking about DevOps in the large. You combine this with an automation solution like Urban Code, for example, that's taking the deployable unit, putting it into the environment. Yep, there you go. We've got a slide for that. You take that deployable unit, put it into an environment, spin up the virtual services that are required, run the tests, get the feedback, give it to development, get them working on fixing or enhancing or whatever it might be. Okay, as you said earlier on, Al, DevOps is all about that feedback loop and making that as tight and as rapid as possible. And using tools like Urban Code and virtual services and automated tests together really helps bring that process together. Speaking of, I believe, Al, the next slide is yours.
Okay, so we've kind of avoided using a lot of product names here, but I really wanted to call out this continuous delivery pipeline, the ability to track our changes, being able to, on the commit of a software change, a continuous integration process kicks off. We have IBM Urban Code Build. We can integrate with a number of different unit testing technologies. Maybe you've got Git and Jenkins, but what we're trying to do is automate this pipeline. So the ability to commit a change, to kick off a build, and then deploy those artifacts into an environment that is dynamically provisioned, where it could be a test environment where we're leveraging virtual services to simulate some of these dependencies. And then as part of my deployment automation process, I want to be able to recycle my test data or refresh my test databases. I know this is another area of time sink for many testers. I want to instantiate or turn on virtual services to simulate these dependencies or scenarios of virtual services. I want to be able to include test automation as part of my deployment process. And maybe I'm using Rational Quality Manager integration where I've got test suites, which are collections of test cases that have been automated. Really what we're getting to here is this true continuous world of continuous integration, continuous testing, continuous delivery to help close that feedback loop in the world and, give us that ability to move these changes into production very quickly. we have a solution that will help you from end to end and includes, the provisioning of the environments that would help us to build trust between dev and ops, where we have security policies in place. We have monitoring included as part of that environment so we can get feedback on performance metrics. And again, it's all about building trust. If I look at a world where the development and the test teams work in isolation, and then they go to the release engineer and say, okay, we're done. Can you please deploy? I ask this question all the time of the operations people and the release engineers. What is your level of trust in the quality, the scalability, the stability, and the security of that application if you've had zero insight into anything that's been done up until the point in time where you get that request? And it is typically zero. Now, if we don't have that trust, then the release engineer, the operations teams have doubt. They're going to start to investigate or look at some of the design decisions, the implementation of the actual functionality, and then they're going to make an assessment as to whether it is compliant with corporate standards to deploy into production. Again, that's another time sink. Bring your operations people into your stand-ups. Bring them up their tasks, the various tasks from these shared infrastructure teams onto your Kanban boards. Have visibility across what everybody's doing. It's going to help with trust. The other thing I like to say is, if we do more comprehensive testing across those various stages en route to the pre-prod environment and into production, I'm hoping by driving the test down, including UI testing, performance testing, security scanning, exploratory testing, earlier on, we can be moving our applications from perhaps early defect discovery and remediation en route to that staging area where we're focused on validation that the application is working properly. And we've got customers that are having success in this. Rabobank, they spoke at Think last year. They talked highly about service virtualization, the ability to dynamically provision environments on cloud in some of the ZOS technologies that can help with accelerating development of mainframe environments. And what's really interesting about this particular case study is they are able to tear down and stand up and run complete end-to-end test cycles 60 times a month. They've seen advances of 10 to 15 times in faster testing than when relying on manual configurations. And through this, speed's the name of the game. So if they're validating quality, they're doing a better level of testing, they're improving their ability to test. They can release with confidence, and that helps deliver on the business results I talked about. These are what the C-level, the managers are looking at is, okay, great, I got, IT teams are working on some stuff to build me this, but how are they contributing to my business success? And that's how we continue to get funding. That's how we continue to get, adoption of DevOps and empowerment to the people to make the right decisions in order to help the company achieve their results. I'd be terrible if I didn't mention in February 12th, we've got Think. We're moving from Vegas to the Moscone Center in San Francisco. The registration link, it's pretty easy one to remember, ibm.com/think if you're interested in going. It's a great place to come out and meet your peers, to meet some of the thought leaders inside of IBM, and Chris and myself or some of our teammates and our colleagues that are very passionate about helping to solve this challenge and working with clients to help them realize the benefits of some of the technologies we have. So with that, Charlene, I'd like to open it up for any questions.
Yeah, okay, great. We've got about 6 minutes to the top of the hour, so I think we can get to 1 or 2 questions here. But there's time. If you guys do have a question for either Al or Chris, go ahead and use your control panel. If we don't get to your question during the webinar, these gentlemen will get a copy of all the questions that come in, so I'm sure either they or somebody from their organization will be happy to follow up with you offline. Okay, first question, how do you manage UI tests which cannot be automated, automation limited scenarios during continuous delivery?
Chris, do you want to take that or you want me to grab it?
No, I'll take a stab at that and see if we get a bit of a follow-up. First of all, I'm interested to know what type of UI test scenario you think cannot be automated. I'm not saying that everything can be automated, because I know it can't, but some specifics around that would be interesting to understand. But yeah, there are situations where there are going to be certain types of tests, UI tests, as an example, that can't be automated as part of a typical CI/CD scenario. But the point there is about understanding the results and understanding seeing at a holistic level, having a view that says, for this release, these are the results of our testing. Okay, and some of that testing was automated. It was done during the CI/CD process. Maybe some of that testing was still manual. But so long as you can see that in a centralized location and you can understand the overall state of testing for that release, I think you're still in a reasonably good place, right? You're still, you're getting the benefit of automation, but you're augmenting it with some of the manual exploratory type of information as well. I don't know if that answers the question. I hope so.
I'd like to build on that a little bit. As Chris said, not everything should be automated or can be automated, and I hope you noticed the highlight of the exploratory testing piece, where sometimes you just need the eyes of a human being and the brain of a human being to look at the situation and determine whether it makes sense. But the value of automation here is that a lot of teams are focused on manual testing their applications. And through all of this manual testing effort, it's taking time away from them being able to do some of those other types of UI testing, that exploratory testing. So if, I saw that, 50% or the bulk of our audience had automated 50% or a little bit more, 50% of their test cases, that should free up some time. Now, with respect to continuous delivery, the continuous delivery solution can absolutely provision the environment, drop the new bits into that environment, and kick off some automated tests. As part of my release plan, as I move from, say, test environment 1 to test environment 2 to 3 to 4 on to staging, as part of my release plan, I can have a step that will kick off that automated deployment, and perhaps I have a manual step where I can then do some of that exploratory testing to satisfy perhaps a quality gate. In order for this application to move from test environment 1 onto test environment 2, it has to meet certain quality criteria. And one of that quality criteria could be that exploratory tests have passed. So there's a way to handle it. Within release automation, continuous delivery typically means that there is one or more manual interventions around that release train, and somebody's going to have to make a judgment call. We typically see it in a pre-prod deployment approval step, but there's nothing saying you couldn't have a manual step that gives pause in that release train for some exploratory testing, the tests that you can't automate.
Okay.
Next question, Shirley.
I'm not sure that we have time for another question, unfortunately. We are at 2 minutes to the top of the hour.
You got that one left there that I think Chris could handle very, very quickly, and I think it's rather important.
Okay, very quickly then. What about old legacy vintage systems / applications, that are terminal mainframe based, terminal emulator based? Do you have CI/CD solutions around that?
Vintage, like a fine wine. So yes, we do. There are a number of different ways of attacking those sort of mainframe-based test scenarios. That could be through green screen automation, which we can provide through our functional test capabilities. That could be through KICKs, IMS, MQ-based adapters, getting in at the more API type level with the integration tester. But yes, we absolutely have capabilities and technologies that can get at those mainframe applications and can be included then in your continuous delivery solutions.
Okay, great. All right, so that is all the time that we have for the questions. I do want to thank those who did submit questions. And also want to remind the audience that this event has been recorded, so if you missed any or all of it, you will be able to access it via a link that will be sent to you in an email, so you can get to the webinar on demand. The webinar also will be living on the devops.com website, so you can always check the website there. Just go under the webinars tab under on demand, and it should be there waiting for you. While you're there, go ahead and check out all the other webinars that we have, both upcoming and on demand. Hopefully there'll be a couple there that pique your interest. Al and Chris, thank you so much for giving such a great presentation. I know I got a lot out of it. I'm sure the audience did as well. So thanks so much for your time. And thank you also to the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.